Welcome back to the channel. Today we are smashing through a fantastic number theory puzzle that trips up so many students under exam pressure. If you want to master how to break down complex word problems into clean, elegant math equations, you are in the right place. Let's get straight into it. First, let's read our problem carefully. X, Y and Z jump forward 4, 6 and 5 feet respectively. At 8 am, they all land on mark 199. How many times will they all land on the same mark? Need not be at the same moment. Between mark 195 feet and 1000, if all of them cross mark 1000 by 9 am? Alright, take a breath. It looks long, it mentions times like 8 am and 9 am, and it feels intimidating. But let's strip away the noise and truly understand what this question is asking us. Deconstructing the logic, let's analyze the mechanics of what's happening here. We have three jumpers moving along a giant number line. Jumper X takes a step size of 4. This means from any mark they land on, the next mark will be plus 4 feet ahead, or the previous mark was minus 4 feet behind. Jumper Y moves in steps of 6. Jumper Z moves in steps of 5 feet. Now look at this crucial clue. At 8 am they all land on mark 199. This is our golden baseline. The question asks, how many times will they all land on the same mark? Notice the phrase need not be at the same moment. Don't let this distract you. This isn't a time tracking problem. It just means jumper X might land on a spot at 8:05 am and jumper Y hits it at 8:12 am. The clock doesn't matter. The geography of the mark does. We just need to find the physical marks on the ground that are perfectly accessible to all three jumpers. So, mathematically, what does a common mark mean? If they all start at 199, any other common mark M must be a distance away that is perfectly divisible by 4, 6 and 5. In other words, the gap, M199, must be a common multiple of their jump sizes. To find the very first gap where they meet again, we calculate the LCM, lowest common multiple of 4, 6 and 5. Multiples of 6 are 6, 12, 18, 24, 30. Bring in 5, and it has to end in 0 or 5, so we jump to 30, 60. Is 60 divisible by 4? Yes. So, text LCM, 4, 6, 5 equals 60. This means a common landing spot appears exactly every 60 feet along the line. We can write this as a beautiful general formula for any common mark, where k is any integer, 0, 1, 2, minus 1, minus 2 dots, 3, 15, crushing the boundaries with inequalities. Now the problem sets the boundaries. We need to find how many of these marks fall between 195 feet and 1000. Let's test our integer values for k systematically. Let's test the baseline, k equals 0. Is 199 feet between 195 feet and 1000? Absolutely. That is our first valid mark. Let's check backward. K equals minus 1. Is 139 feet within our bounds? No, it's way below 195. So we can't go backward. Our starting line is locked in at k equals 0. Now let's look forward. Instead of adding 60 over and over like a turtle, let's use algebra like a pro. We want to find the exact moment our marks hit that upper ceiling of 1000. Let's set up an elegant inequality. Let's solve for k. First, isolate the 60k by subtracting 199 from both sides of the equation. Now, divide both sides by 60 to get k by itself. Boom! Because k represents the number of full 60-foot intervals we are jumping forward, it absolutely must be a whole counting integer. You can't take 0.35 of a common jump. So the absolute maximum integer value k can reach is 13. 450. The grand count. Here is the final boss trap, where most students lose their hard-earned marks under exam pressure. They solve the inequality, see the number 13, and immediately sprint to circle option B. Don't fall for it. Remember where our sequence started? Our valid values for k started at 0, not 1. Our complete list of successful k values is 0, 1, 2, 3 dots all the way up to 13. To count exactly how many terms are in this sequence without making a careless mistake, use the standard arithmetic progression counting formula. There are exactly 14 common marks where all three jumpers will leave their footprints. We checked the exam paper, and option D is our absolute winner. If this high-energy, step-by-step mathematical breakdown made this question crystal clear for you, make sure to smash that like button, hit subscribe to join the channel, and drop a comment below on what exam puzzle we should conquer next. Keep practicing, keep crushing it, and I'll see you in the next video.